disclosure brought to you by InfinityExist.com. I'm Knox, this is Patch, and today we're going to do a very in-depth episode on Ettercap.
Basically, Ettercap is made to sniff passwords on the LAN. You'll be able to sniff any packets that are sent to your computer if you're on a hub and it's broadcast to everybody, or you can utilize man-in-the-middle attacks to redirect those packets to you and then sniff it that way.
In this episode, we're going to cover 3 different man-in-the-middle attacks. We're also going to do sniffing SSL traffic, Ettercap filters, Ettercap plugins, and we're also going to touch on passive OS fingerprinting.
Alright, in this video we're just going to be using Backtrack 2. So open up the console. As you can see, there's a whole bunch of options you can use with Ettercap. But basically we're just going to use the GUI interface. You can use an all-text interface, you can use the curses interface, which is kind of like a text interface that looks like the GUI interface. It's just Ettercap-G, and then I'll open up the GUI. And there's 2 types of sniffing options. There's the unified method, which will sniff all packets that pass through your cable. You can choose to put your interface into promiscuous mode or not. If you're on a Windows computer, most likely you're going to want to disable that, because it seems that most wireless cards have problems using it. Basically, promiscuous mode configures your network interface to send all traffic to your CPU instead of just packets that are addressed to it. Also, the packet is not directed to your computer. Ettercap will automatically forward it using a layer 3 routing. This will be invasive on a gateway, so what you want to do is you want to check the uninvasive mode. So yeah, if you're using Ettercap on your gateway, you want to enable the unoffensive mode. Alright, and the reason why we're using the Linux version of Ettercap is because Windows, I've experienced, has problems forwarding the traffic, and it usually causes a denial of service attack. But that could depend on your drivers and what type of network card you have. The second sniffing option is a bridge sniffing option, which it will use 2 network interfaces and forward the traffic from one to the other and sniff the packets as it crosses over. This sniffing method is completely stealthy, since there's no way to detect a physical man-in-the-middle attack. Basically, you're in the middle of the cable. Alright, we're just going to select the unified sniff, and we're going to select our Ethernet interface.
Alright, for our first man-in-the-middle attack, we're going to do ARP poisoning. In ARP poisoning, what happens is the attacker will send out requests and replies to the victim, and that will poison the ARP cache. This will allow you to receive all the packets sent out, like being the man in the middle, so you can receive the packets, sniff them, and they'll continue on to the destination. So in Ettercap, if you go to targets and open the current targets, you can see where you can put your targets. In Ettercap, there is no concept between source and destination, it's just between 2 hosts. So for ARP poisoning, we need to first scan for all of our hosts on our current network. If you go under the host list, you can see the 2 stations we have. You can then add those to the target list. You can add to target 1 and target 2. This will do this man-in-the-middle attack between those 2 hosts. And if you don't add it to those 2 targets, if you leave the target fields blank, it will be for all hosts on that network. And of course, go to man-in-the-middle attack and select ARP poisoning. You can also see under ARP poisoning there's an option to do only poison one way. This is helpful if you want to poison only the client and not the router. This is helpful because sometimes they put ARP watchers on the routers. And we're going to select OK, and of course go to Start and select Start Sniffing. Ettercap comes with some helpful plugins for ARP poison. The first one is check poison. This will check to make sure that your ARP poison was successful. As you can see, ours was. And another helpful plugin is repoison. This will repoison the ARP cache every time a new host is added. Alright, here we are in the victim. As you can see, both the gateway and the attacker have the same MAC address. That shows that the poison was successful. Alright, to test out our poison, we're going to go to YouTube and we're going to go ahead and log into the site. As you see on Ettercap, it has picked up that password, shows you where it's from, what the username is, and what the password is. So our poison was successful, without the victim being the wiser. Once we've ended the ARP poison, if you go back to the victim, you can see that the MAC address is returned to the original one. It restores that ARP cache. For the next man-in-the-middle attack, we're going to cover DHCP spoofing. DHCP stands for Dynamic Host Configuration Protocol. What DHCP does is when a new host is connected to a network, it hands out to that host an IP address and what the gateway is. So in DHCP spoofing, what it does is use Ettercap to beat that DHCP server to the host and give it your information, so it thinks that you are the default gateway, so all the information will come to the attacker.
And since it only thinks that you're the default gateway, it's only a half duplex man-in-the-middle attack. That means only data going out to the internet will be captured and not data coming back in, because it's only configured to be, as the attacker, to be the default gateway, so it doesn't get that kind of traffic. This is important when you're doing various filters and different attacks like that.
Alright, so for DHCP spoofing, it's pretty simple. When you open it up, there's three different fields. There's the IP pool, which is optional. There's the net mask, and the DNS server IP. You don't have to put an IP in the IP pool. If you don't do this, it will get the IP from the current DHCP server. So because you're in a race against the other DHCP server, it's wise to put in an IP pool. That way, you have an IP address that you can give it right away and it doesn't have to wait. Also want to put the net mask and what would be the DNS server, which is your default gateway. And you can find all this information just by running a simple ifconfig. You can see our current address, you can see the net mask there. Go ahead and hit OK. You want to make sure you remove the two targets from the previous attack that we did, which was our poisoning. Alright, so here we are in our victim machine. First, we're just going to show you the current, as you can see, our current default gateway is .1 and our current IP address. And so we're gonna simulate a new host connecting to the network. We're going to release our IP address and then we're going to request a new one by IP config/renew. So when we type that command, it's going to request what the victim thinks from the DHCP server, but really we're going to be handing out that IP address and that default gateway. As you can see, it was successful. You can see the different requests that come in and us giving back an IP address and a default gateway. If you take note of our IP address and we go back over to the victim and we do another IP config, you can see that the default gateway has been changed to our IP address. Now, just to test the attack, we're going to go ahead and connect to our FTP server. As you can see, the username and password were recovered.
Last man-in-the-middle attack we're going to cover is port stealing. It's a good attack if you're in a switch environment. There's some type of ARP poisoning prevention. Basically, for a switch to know which MAC addresses are connected to which ports, it creates a CAM table, which is a simple mapping between those two things. And if there's no port security, the CAM table is created dynamically when a host connects or disconnects. And it builds these CAM tables by monitoring packets, the packet source and destination MAC addresses. This will allow Ettercap to be able to spoof packets to manipulate the CAM table and make it think that you are the host that it's supposed to send data to, when it's actually supposed to be sending it to another port. Alright, just go to the man-in-the-middle tab and select port stealing. And we're going to select the option to sniff remote connections, because obviously that's why we're doing this attack for. And then there's a second option to propagate this attack to other switches. If you don't check this option, the destination MAC address of each stealing packet is the same as the attacker, so that the other interfaces on the network won't see these packets. And the source will be the MAC address of the victim. The switch will record the source address of the packet against the port it came from, i.e. the attacker's port is mapped to both the attacker's MAC address and also the victim's MAC address. The switch will now direct the next packet targeted for the victim's MAC address to the attacker's port based on the CAM table. Thus, the port is stolen. When the attacker receives the packet from the stolen host, it needs to restore the CAM table back to its original state, i.e. with the victim's port mapped to the victim's MAC address in the CAM table. This is achieved by issuing a broadcast ARP request for the victim's IP address. When the victim responds, the switch will record the new CAM table mapping back to the original. And then to get the next packet, the attacker will have to repeat this entire process over again. This seems like a lot, but it can be done in a matter of seconds. If you do select to propagate to other switches, which we will for this attack, because we're going to have two switches connected with the attacker on one switch and the victim on the other, basically the destination MAC address will not be the MAC address of the attacker. It will be just some random one. So the packet will be propagated to other switches, not just the switch it's directly connected to. This way you'll be able to steal ports on other switches. But of course this is going to create a whole bunch of traffic, so if you're on a huge network, this is probably not a good idea. Alright, we're just going to run the attack. Before we can start this attack, we need to create a host list. So we're going to do that, and then we're going to run the attack. Alright, we're on the victim's computer again here, and we're just going to have it go log into YouTube. As you can see on the attacker computer, it did capture the username and password. And that's pretty much it for man-in-the-middle attacks. Next we're going to show you how to sniff HTTP traffic over a secure socket layer, known as HTTPS. Basically, Ettercap will create a fake certificate based on the real certificate and substitute it for it, allowing you to capture all passwords that go over the secure layer. Before we can do this, we need to exit out of Ettercap and modify the config file, which is found in user local etc ether.config. Just going to scroll down here, and when we get to redirect command on and off, we're going to uncomment the use of IP tables and just save it and exit out. And then we're going to start up Ettercap again and Basically, we're just going to scan for hosts and do a basic man-in-the-middle attack like before. We're just going to use ARP poisoning just because it's simple. If you notice that your victim's getting a denial of service, it's probably having a problem with Ettercap forwarding the packets. So what you want to do is re-enable IP forwarding done by your operating system. To do this, you just do echo #1 in quotations caret prc-system-nes-ip version 4-ip forward. That will re-enable IP forwarding. Alright, but it seems like everything's working out fine right now. We're back on the victim's computer, and we're just going to show you that you can capture secure socket layer traffic. Basically, I'm going to log into Facebook here, and you'll see the fake certificate pop up, and all you have to do is accept it, and you'll be able to intercept the packet, as you can see right there on the attacking computer. Another common website that uses HTTPS is Gmail. So we'll just go there, and you'll notice that the certificates pop up right away, and there's about 3 of them. And if the victim accepts all 3 of them, you'll be able to sniff, 4 of them, I guess. You'll be able to sniff the packets from Gmail, as you can see right there. Alright, now I'm just going to exit out Ettercap, and I'm going to change the config file back to the original settings.
Next we're going to cover filters in Ettercap. This allows you to easily modify the network traffic. Alright, here are the basic script functions. There's search, which allows you to search for a string. There's replace, which allows you to replace a specific string with something you specify. Inject will allow you to inject a full packet. Log will log the packet. There's message, which will display a message in Ettercap when a specific piece of data comes through. Drop will drop the packet so it is not received to the destination. Kill will kill the connection between a host and a destination. Execute will execute shell command, and exit exits the filter.
Alright, Ettercap comes with a few examples of filters, and you can get to them by going to user-local-share-Ettercap. I'll just show you a couple here. This first filter is pretty simple. All it does is check to see if the packet is THCP, and then it'll search the packet to see if it finds the incorrect spelling of Ettercap. And then what it'll do is log that packet, and then replace the misspelled Ettercap with the correct spelling of Ettercap, and then display the message that it corrected the substitution. It's just a simple filter to give you an idea of what you can do with it. Alright, this next one has a whole bunch of different examples in it. The first one here just checks to see if it's on the port 22, which is a SSH packet, and just displays the message that an SSH packet was found. The second one looks for telnet traffic, and then it'll execute some sort of command and log that data. And then, yeah, it just keeps on going on like this. One will look for Ettercap in a packet, and if it finds that, then it's going to kill the connection and drop the packet. And there's just a whole bunch of like this, and there's examples. You wouldn't actually run this filter as one thing, so just kind of gives you an idea what you can do. The next one is the kill filter, which basically, if it's from a certain IP address, it will just kill the connection and drop the packet. It's that simple. And the last one that comes with it is actually pretty advanced. Basically, it's an SSH downgrade. We covered SSH servers before, and basically when you connect to an SSH server, it will tell you what version it's running, and if it's configured in a certain way, it'll allow you to either connect with the lower version or the more up-to-date version. Then what Ettercap will do is modify the packet that is sent back to the client and make it think that it only has a lower version. thus a version downgrade. Alright, I'm just going to edit this example file and just do a simple example. Basically, I'm going to search all packets for InfinityExist.com, and if it finds that any packets, what it'll do is drop that packet and kill the connection. So basically, whenever someone is going to a website where there's a link for InfinityExist.com, or you go to the InfinityExist.com website, it'll just kill that packet, not allowing you to go to it. Alright, I just modified it here, and I will save this packet by pushing Control X. And I'm just going to save it as ether.filter.examples2. And as you can see, that's the modified one. And to compile this script so it can be used in Ettercap, you want to use the command etherfilter, and then type the location of where your filter script is located, and then -O, and then the output file where you want to put the script. And I'm just going to output it to examples.ef, EF standing for Ethercap filter. And now this filter is in a way that Ethercap can understand it and use it. So I'm just going to run Ethercap again. I'm going to scan for some hosts and just run a basic ARP poison attack. You could really use any man-in-the-middle attack for this one. The DHCP spoofing one would not work all the time because, like I said before, it's only half duplex and it only sees outgoing things. But we're just going to do ARP poisoning because it works both ways, full duplex, just like port stealing is. And we're going to go to filters and load a filter, and we're going to find the example.ef. It's, as you can see, the filter dialog box is already in the right directory, so we just have to scroll down and find it, and just click on it, and it'll automatically load it into Ethercap. And now we just go to the victim's computer, and as you can see, it is not allowing us to go to InfinityExist.com. Now you could do this for anything. You could be like, I don't know, let's say you're like a parent and you want to prevent your child from looking at porn. You can do search for porn, and then it'll automatically drop those packets. You know, whatever. You can do whatever you want with this. As you can see, the message was displayed on the Ethercap. Alright, we're just going to stop that filter, and I'll show you a different one. The next one we're going to show you is their kill example. And what we're going to do in this one is any packets that have the source IP from our victims, which is 192.168.15.4, as you can see in the host list, it'll kill that traffic. So basically this will kill all outgoing traffic from the victim. I'm just going to save it and use etherfilter to compile that that script again, load it up in Ethercap, and we'll hop on over to our victim computer, and you'll be able to see that we cannot connect to anything because all outgoing packets are dropped. See, we can't even ping, we can't do anything. Alright, the next filter I'm going to show is pretty much the typical filter that everybody shows when they make an Ethercap video, so we might as well show it to you. It's Iron Geek. It's his filter to modify pictures, to change them. IronGeek.com is a great source for hacking tutorials just like us, so check them out. But I'm just going to copy the source. Basically what it does is the first part will remove any encoding, basically remove the encoding so it's in clear text, which could prevent some pictures from being changed. And then you can see the second part replaces image source equals to a different image source equals, and then it'll replace it to one of Iron Geek's pictures, and you'll see that in a moment. basically I'm just going to save this and compile it with ether filter again, and load it into Ettercap, and let's hop over to our victim computer again, and let's go to infinitysys.com and you'll see how it works. As you can see, the pictures on Infinitysys were changed. And you could do this with any picture. You could do this with, you don't have to do this with images. You could do this with text. You can do it with anything. Alright, we're going to show you one more filter. Basically, I made this filter to be able to intercept WordPress passwords. Our website is based off WordPress, and if you log in and you have a sniffer running like Ettercap, you notice that it's not detecting the WordPress passwords. As you can see, nothing's showing up. So I designed a filter to be able to intercept those packets, and I'll just show you how I made this. Basically, I'm going to open up Wireshark, which is a packet sniffer, but it shows you, unlike Ettercap, it will show you every single packet, not just the passwords. And I'll just run it here, and I'll just switch back to the victim's computer once again and log in. And you'll notice on the attacker computer again that a whole bunch of different packets are popping up. This is showing all the traffic. And we're just going to kind of go through these packets and see if we can find it. Because we know that it's not using the secure socket layer, so it must be in clear text somewhere. And if you just look through a few of these, you'll eventually find it. And if you look closely at this packet right here, which it's helpful to realize that it's coming from the source as a person that's on the LAN, so 192.168.4, and going to a remote destination. Now let's copy the contents of this packet, and you'll see that it has the login equal to Apache and the password equal to Infinity. So basically I'm going to make a filter around this, so I'll be able to easily capture these WordPress passwords. And this is it right here. Basically what it does is check to see if the packet is THCP, and if it's going to the destination 80, which is the port that web servers run on. And basically it will search that packet to see if it can find PWD equals, which is what we saw in the packet when we were looking at it in Wireshark. It searches for that, and then if it finds that, it'll display a message on Ettercap saying that it found a WordPress packet, most likely, and then it'll log that packet in a temporary log, as you see right there, the last line. Once again, I will compile this script with etherfilter and load it into Ettercap. And I just wanted to mention once again that we are still running the man-in-the-middle attack, because to use filters you have to have a man-in-the-middle attack running. Alright. And we'll just hop back onto the victim's computer and we'll just quickly log in again. As you can see, it popped up a message that a WordPress packet was logged. And if we go to that log file, we'll see that it was indeed logged, and we can clearly see my password. Alright, it's right there. And that's pretty much it for filters. You can do so much things with filters. It's basically kind of like a simple C language, just doesn't have that much stuff you can use. There's only a couple commands. But it's kind of structured the same way with if statements, and the syntax is kind of the same. Next, we're going to show you a whole bunch of different Ettercap plugins. We're going to show you DNS spoofing, and we're also going to show you two different denial of service attacks, and we're going to show you a couple of plugins that you can use to try to find sniffers on your local network. Alright, the first plugin we're going to show you is DNS spoofing. To get the plugins, you go to the Plugins tab and then go to Manage Plugins. Basically, a DNS server is a server when you type in a URL for the website, you'll send this URL to the DNS server, and it will reply with the IP address to that website. Basically, what Ettercap does with this plugin will intercept that request and then reply with a fake IP address. Basically, what this means is when you go to like infinitysys.com and you have a DNS spoofing running, it will send back an IP address of a different web server, and then that web server's data will be sent to the browser instead of InfinitySys data, which you'll see in a few minutes here. Alright, before you can run this plugin, you need to configure the ether.dns. Basically, it tells Ettercap which DNS requests to spoof. There's a few different types of intercepts you can configure. There's A, PDR, and MX. The one we're going to be using is the A request. You'll search for the URL and then return an IP address. As you can see here, this is kind of the syntax for this. The example they use is Microsoft.com, and then they'll use an A type request, and then they'll send back the IP address for Linux.org. So basically, what will happen is when you go to Microsoft, it will send you to Linux.org. You can also use a wildcard. As you can see, there's a wildcard.microsoft.com, which will basically be like if you go to www.microsoft.com or like mail.microsoft.com or automaticupdates.microsoft.com, it'll intercept all those requests and send it back with the linux.com IP address. Also, you can just use one asterisk, which will mean every single URL that is sent to the DNS server, it will send back this IP address. So every single website will be redirected to linux.org. But for this example, we're not going to do that. We're just going to search for infinitysys.com requests, and we're going to send back the IP address of this machine. We're going to send back the IP address of the attacker machine, which is, as you can see here, 192.168.15.6. So, and then we're going to use the same one with an asterisk.infinitysys. That means if they type in www.infinitysys or mail.infinitysys or whatever, it will still intercept that. And then we're going to run an Apache server. You can do this by going to services, httpd, and then start httpd. And as you can see, the Apache server was started, and you can see that the contents of this server are stored at user-local-apache-htdocs. And basically we're going to browse to that folder, and we're going to create an index.html. We can put whatever you want in this index file. I would imagine that most people would do like a fake website to be able to phish passwords, or you can do whatever you want. But I'm just going to do a simple pretend like InfinitySys was hacked. I'm just going to test it out to make sure it's working properly. I'm just going to go to the local host, which is 127.0.0.1, and as you can see, it is working properly. Alright, so everything's set up properly in the DNS config. We're just going to save it, and we're going to open up Ettercap. We are going to do a basic man-in-the-middle attack. You could do any one of the three that we showed you. They would all work. And we're just going to do art poisoning once again, just because it's the simplest one. It's used the most often. We're going to start sniffing. And we're going to enable the DNS spoofing plugin. As you can see here, it was activated, and you can tell that it's activated in the plugin menu by an asterisk. Alright, we're back on the victim computer, and as you can see, we'll open up infinitysys.com here, and it seems to the victim that InfinitySys was hacked. It sends back this information to it. Like I said before, you could put in any IP address you want. You can make it you can make it go to a different website. You could run a server like I'm doing here, and you can put any content you want on there. One thing that will happen, as you see, if I go to any subdirectories, it will pop up a not found, because on my server that I'm running off this attacker computer, it does not have a videos directory or forums directory. So it's obviously going to respond with the error that it's not found. And if you go back to Ettercap here, you can see that it displays a message when it spoofs a DNS response. Alright, I'm just going to disable that here, and we'll show you a couple more.
Alright, for the next plugin, we're going to show you the isolate plugin. The isolate plugin will isolate a host from the LAN. It does this by poisoning the ARP cache with that host's own MAC address. So anytime it tries to send out, it's connecting basically to itself. How this plugin works is under the target list, in target 1 is going to be the victim computer, and you can choose to leave the target 2 field blank. If it's blank, it'll do all requests sent out, so it will deny service for anything from that host. But you also, in target 2, you can put in specific hosts that, like for requests to go to a certain host, it'll deny service just for that particular connection. Alright, as you see, when we've under plugins, after we've activated the isolate plugin, you can see that the victim has been added to the list, to the host list. And if we switch over to the victim computer, we can see that it doesn't allow us to connect to the internet. It won't allow us to do anything. It's sending that request, looping it back to the local computer. And just to clarify, you don't need to be running a man-in-the-middle attack for this to work. I guess we just had Ettercap crash there on us. Ettercap shouldn't crash on you. We had some problems during the installation, but that plugin should work just fine for you. Alright, we're going to restart up Ettercap here. Alright, so the next plugin we're going to show you is the DOS, or Denial of Service Attack, and we're also going to be using the Find IP plugin to help us use that DOS attack. Alright, basically how this DOS attack works is first it'll scan the victim to find all of its open ports. It'll flood those ports with SYN packets, which are request packets. It will get the request acknowledgement packet back, and then it will send an acknowledgement packet back. This is all with a phantom host, so it's with an IP of a host that doesn't exist on the network, and it'll establish this basically fake connection between these two hosts. But first we have to find an IP on our network that isn't being used, and that's where the Find IP plugin comes in. And just so you know, you need to make sure you generate that host list before you use Find IP. Alright, we're going to go down to the Find IP, we're going to run it, and it's going to list an IP address that it believes is not being used on our network. In this case, it's 15.2. And then we're going to go ahead and run the DOS attack plugin. It's going to ask for the victim's IP, which we have from our host list. So you can see there, it's on the host list. Go ahead and put that IP in for the victim. And then it's going to ask for an unused IP address, which we got from running the Find IP plugin. And as you can see, it started the DOS attack. Now let's go over to the victim computer and test it out. As you can see, we have zero connection. We cannot do anything. Denial of service. Alright, the next plugin we're going to show you is Gateway Discover. This isn't really applicable on our current network because we know the default gateway, but on a wireless hotspot where they might hide the gateway, this can be really helpful. Basically, this works by sending a request packet to a remote host. It has to be a remote host, like a web server, and then Ethercap will receive the request and acknowledgement packet from that host, which will contain your network's gateway address. Alright, so we're just going to go ahead and run the plugin here. As you can see, it's asking for a remote IP. So we're just going to go open up the terminal, and we're going to get the IP address of google.com with nslookup. As you can see, the address right there, copy it over and paste it in. All web servers are on port 80, so just put :80 for the port. Okay, well I guess that didn't work, so let's try our website. Port 80. And that didn't work as well. So obviously something's wrong, and the sniffer is not running. That seems to be the problem. So you make sure that your sniffer is running when you run this plugin. Go back, we'll paste it on our website again, and there we go. It has found the gateway of our local area network. Again, this doesn't really apply to our network because we know what it is, but it can be very helpful in situations where the default gateway is hidden.
Alright, there's 3 more plugins that we want to show you, and they're basically designed to find attackers on your network. First one we're going to show you searches for computers in promiscuous mode. And we're just going to hop on over to our other computer, the victim computer, and we're going to open up Ethercap, and we're going to start a sniffer that's in promiscuous mode. And then if we just run this plugin, it will tell you network interfaces that are most likely in promiscuous mode. You may have to run this a couple times to get all the network interfaces to show up there, and also you got to be aware of that there could be false positives. Also, it shows you less probable sniffing interfaces, and there's none right now because we don't have any other hosts. But yeah, the next plugin we're going to show you is Ettercap. Basically, this is a plugin that runs constantly, and it constantly looks for suspicious ARP activity by passively monitoring ARP requests and replies. And we're just going to go to our victim computer over here, and we're going to run an ARP poisoning attack. And Ettercap will automatically, as it sees the suspicious ARP activity, display the message on the screen. As you can see, it's saying that the victim IP address 192.168.15.4 is pretending to be an IP address that's not. We're just going to disable Ettercap so it stops spitting out more warning messages. And I'm going to show you the last one. It's scan for poisoners, and basically this will just do one scan. It won't continuously report activity like Ettercap will. We're just running here, and as you can see, it tells you that the victim computer is pretending to be the gateway. So you can see that there is uses of Ethercap to not only do attacks but to prevent attacks. The last Ethercap feature that we want to cover is passive OS fingerprinting. Basically, passive OS fingerprinting is a technique that's based on analyzing packets that are sent in usual communications. It doesn't generate any new packets, so it's pretty much undetectable. Basically, these packets that are done in normal traffic between two hosts contains enough information to figure out like what operating system that remote host is running, and you can even figure out like open ports and what's running on those ports, and we'll just show you that. To view the profiles that Ethercap creates on remote hosts by passive OS fingerprinting, go to View and then Profiles. And obviously you have to have the sniffer running, to be able to capture these packets. So that's pretty obvious. And we'll just open up a web browser here and go to infinityzist.com. And if you go back, you'll see that there's a profile automatically created for our website. And if you open it up, you can see that it knows what operating system it's running and what web server it's running, just by passively monitoring these packets. Also, it gathered information on our gateway, and if you open that up, it can tell you what kind of services they're running, and it'll tell you that it is the gateway. This is kind of a third-party router, so it doesn't know much more about it. But yeah, basically, if you're communicating with a remote host or anything that you are communicating with, Ettercap will automatically, from these packets that are being transferred between your computer and the remote host, it'll build a profile on that computer. Also, this profile on the gateway contains the MAC address, so you get that from there without sending out any packets, without doing anything on the network. So it's undetectable. And that's pretty much it.
That's it for this episode on Ettercap. I also do want to mention that our Underground series is up and running. We have 2 videos now. So we want your submissions, so please go to the website and submit your videos that you've made to us.
We know this episode was pretty lengthy. It probably was pretty confusing at parts, so if you have any questions, just ask them on the forums and we'll try to get back to you with some answers.
I'm Knox, this is Patch, we're out.